The first satellite ever successfully launched into space was Sputnik 1. It was launched by the Soviet Union in 1957. Then, in 1958, Explorer 1 was successfully launched by the United States. This started the space race. Sputnik and Explorer started the thought of satellites, and after that we started to create many different types of satellites using the information collected. One of these was the first communication satellite, Echo 1, which was essentially a big balloon and waves bounced off it from one place on Earth to another. Communication satellites of today are used for much more than Echo was. For example, some of the communication satellites are used for phone calls, others for watching TV, and some for listening to the radio. An example of a communication satellite today is Anik E. Another early satellite was TIROS-1, the first weather satellite. TIROS-1 proved that it was possible to monitor the Earth's cloud cover and weather patterns from space. The weather satellites of today have taken this a step farther than just cloud cover and weather patterns. Now weather satellites, like Meteosat, can take radiation measurements from the Earth's surface and atmosphere, take the temperature of the sea for fishermen, monitor the amount of snow in the winter, the movement of ice in the Arctic and Antarctic, calculate the depth of the ocean, examine crop conditions, areas of deforestation, regions of drought, and monitor volcanic eruptions. Like some weather satellites, atmospheric studies satellites study the Earth's atmosphere. Alouette is an example of this satellite. Canada launched Alouette to study the ionosphere so they could know more about the northern lights because Canada wanted to know why they disturb radio communications. Search and rescue is also aided by satellites. The first rescue aided by a satellite was in September of 1982 by Cosmos 1383. The idea came from the weather satellites because they get some data from buoys and need to know where that particular buoy is. Satellites fly over a beacon calling out a distress signal and then use the Doppler effect to find the coordinates within 4 kilometers. The Doppler effect works by sending a signal down to where the beacon is, and then the resulting shift of the wavelength of the signal coming back is used to calculate the distance. This is like when you hear a train whistle and you know about how far away it is because of how loud or quiet it is. Another type of satellite that uses the Doppler effect is navigation satellites. This is especially useful for boats because they are on the ocean and it would be hard for them to find their position without the help of a satellite. Another type of satellite is the remote sensing satellite. It observes and measures our environment and monitors resources important to humans. Some specific uses are tracking animal migrations, locating mineral deposits, watching crops for weather damage, and seeing how fast the forests are being cut down. They're extremely effective because they can easily monitor the land that might be a lot harder to reach through other means. Another early satellite was Friendship 7. It was the first manned satellite. This helped bring the United States back into the space race after the Soviet Union launched their manned satellite. This eventually led to the International Space Station, which took the idea of Friendship 7 and made a manned satellite able to stay in space and functional for longer. Since it orbits the Earth about every 90 minutes and is about 220 miles from the Earth, the combination of speed and distance allowed the International Space Station to stay in orbit despite the gravity of Earth. The International Space Station is powered by about an acre of solar panels, which produce enough kilowatts of electricity to power more than 40 homes on Earth. These solar panels rotate so that they face the sun at all times to ensure that there is constant power. There are also batteries on board so that when the Earth is blocking the space station from the sun, there is still power. Another form of satellite is an astronomy satellite. An example is the Hubble telescope. This is basically a huge telescope in space, and because the Earth's gases don't block it and the Earth's heat doesn't confuse the infrared systems, it can get a clear picture of something far away in space. It does this by analyzing the electromagnetic waves of whatever it wants a picture of. There are also spy satellites, called reconnaissance satellites, which are used to spy on other countries. There are 4 types of reconnaissance satellites, which include optical imaging satellites, which can see enemy weapons on the ground, radar imaging satellites, which use radar to observe Earth, signals intelligence satellites, which pick up radio transmissions, and relay satellites, which send spy data from satellites to stations on Earth. Another important part of satellites is the orbit pattern. One kind of orbit is a low Earth orbit, or LEO. These satellites orbit at a height of between 100 and 1,240 miles. Some satellites that use LEO are most communication satellites and the International Space Station. These satellites need to move faster than satellites higher up so they can stay in orbit. One problem with LEO orbit is all of the space debris there. There are over 8,500 pieces of debris over 10 centimeters, which can be a problem because of the possibility of collisions. A second orbit pattern is geostationary orbit, or GEO. These satellites orbit at a height of about 26,000 miles and orbit at the same speed as the Earth, so they appear to stay in the same place. Some examples are direct broadcast and communications or relay systems. This is because they stay in the same spot and an antenna can connect easily to the satellite. One of the problems is that GEO satellites stay above the equator and because of this cannot provide polar coverage. It also requires there to be 3 stations spread equally across the globe for full coverage. Another problem of GEO satellites is the distance. This is why there is a delay in some long-distance phone calls and on the news when they ask a broadcaster a question and there is a pause before their answer. GEO satellites can also be pulled off of their orbit by the moon and sun. These satellites do carry fuel though, so they can fix this problem and get back to their correct position. Yes, there are a lot of problems with the GEO satellites, but they do have a big pro, and that is staying in the same spot over the Earth all day. The third major orbit pattern is highly elliptical orbit, or HEO. These satellites orbit at a low height of below 621 miles and at a high height of over 22,000 miles. As the name implies, HEO satellites follow the curve of an ellipse. One of the key features, however, is that when it is close to Earth, it moves much faster than when it is farther away. There are 2 focal points of HEO orbit. One is the geocentry, or when the satellite orbit forms a plane that passes through the center of Earth's gravity, and the other is the apogee, or when the satellite moves at a slower speed because the gravitational pull is lower. A major perk of HEO orbit satellites is that it's possible for them to provide coverage over any point on the globe. Russia uses a lot of HEO satellites because they need coverage near some polar areas and GEO satellites can't achieve that. Satellites have progressed a lot since Sputnik and Explorer. We now have different orbit patterns and different uses for our satellites, and they will only progress from here.